Okay, so question 3, we've got a question about reflection and refraction. So ray of light travelling to a plane mirror, so that just means a flat mirror. Draw the ray of light after it reflects off the surface. So we know all surfaces reflect, but if it's a plane mirror surface, which would show with a hash behind it like that, then we know that the angle of incidence will equal the angle of reflection. So we've just got to make sure we draw a ray where that angle, theta I, is going to equal this angle here. And then we know that we've just got to draw a ray that is continuous, goes from that normal, and has an arrow on it. So there we go. And theta I equals theta R. The angle of incidence equals the angle of reflection. Next one, we've got refraction. So I say to you things like get yourself a pencil or a pencil sharpener and pretend you got a car, moving it in, brum, brum, brum. Side A, so for light, we know that it slows down when it enters the more dense medium glass. So this side's slow, that's still going the same speed, so it's going to swing that way. So we know we just got to move the line towards the normal. So if we imagine carrying that on, somewhere in this area is where we need it. So now we're going to bend that ray at the interface, at the boundary, down like that, 2 marks. So one for showing that it bends and one towards the normal. Here, one for showing it reflects with a continuous ray and an arrow, one for having the 2 angles the same. Next one, we've got water is in light, and here is air. So what we're going to see now is, depending on this angle, it'll either bend and move away from the normal, or if it's larger than the critical angle, so at the critical angle, it'll follow along there. Larger than the critical angle, we're going to have total internal reflection. So again, we're just going to have a ray reflecting from that surface, bang, and in effect, it'll end up doing that. Okay, next one, converging lens has a focal length of 40 centimeters, and it tells us underneath here, we're going to need to change that into meters. What's the power? And it gives us that formula. Power equals the number 1 divided by the focal length in meters. So centi divided by 100, that's going to give us 0.4 meters, and plumb that in. So 1 divided by 0.4 equals 2.5 diopters. And the symbol for that would be a capital D. And there we go, that's that question done.